Hello and welcome to my client-side desync demo. Here I have set up a simple website that is vulnerable to a client-side desync attack. And we can start by going to the inspection panel, and in the network tab, we can see that two requests are being made. The first for our index page and the second to request an additional JavaScript resource. Notice here that both requests are being sent with the same connection ID. This is important for our attack since this means that there is a persistent connection that exists between the browser and the web server. This means that we should test for a client-side desync vulnerability. We can do this using fetch in our browser's console. Here, we are sending two requests right after another. The first is a post request to a static resource with a GET request smuggled in the body. So if our site is indeed vulnerable to client-side desync, the content length of this request will get ignored and cause a desync of the browser-server connection. We see here then a second request is sent immediately following the first to the login endpoint. However, if our connection was indeed poisoned by the first request, then the malicious prefix from our first request will cause our second request to end up on the 404 error page instead. So here we can hit submit. And notice that we do indeed end up at the 404 error page, and there is a mismatch between what we see in our address bar and what page was actually fetched. So therefore, we have confirmed the client-side desync attack vector. Now let's see what an attacker can actually do to chain other attacks. For this, we will also be exploiting an open redirect vulnerability in Werkzeug, which allows attackers to redirect users to arbitrary external sites. We can see this using Burp Suite as sending a request for endpoint starting with HTTP or HTTPS will result in a redirect. Notice that this redirect isn't a simple 302 redirect, but instead a 308 permanent redirect. This type of redirect will force our browser to cache the result for further usage. So our goal here will be to use this in conjunction with client-side desync to poison the location of the script main.js for our index page. To see this attack, I have set up a malicious attacker-controlled website at localhost on port 6119. As we see here, when the victim navigates to the exploit endpoint, it sends a post request to the index page with a GET request for our malicious site in the body. Recall that when we visit the index site, a second request for main.js is automatically triggered. That request will get poisoned by our malicious header here, which will then trigger a permanent redirect since the endpoint we are trying to access starts with HTTP. That request will then it will cache the contents of our malicious JavaScript seen here at main.js. So now every time the victim visits the index page and fetches the main.js JavaScript, our malicious JavaScript gets executed from cache instead. So let's see this in action. Typically, a victim will be lured to the attacker-controlled website through a phishing email or some other social engineering technique. So here we see that we have an email from presumably an attacker, and when we click it here, this is a link to our malicious site, and if all went well, our malicious JavaScript is executed instead of main.js and also cached. So here we can see that we've stolen the user's cookies. So since this is cached, the next time we visit the target site as well, it will trigger the same behavior. So that was a quick demo of the CSD vulnerability and one of the many exploit chains that are possible with this kind of vulnerability in attack.